Hi COMEDK 2025 aspirants. So I hope all of you are preparing really well for your exam, and in today's video we are going to solve the top 30 questions from the chapter Chemical Kinetics. Okay, last year in 2024 almost 4 questions were asked. I think 5 questions were asked from this chapter, so it is a very important topic as well as a very scoring topic. So let's watch the full solution. After watching this video, I hope that you will be able to solve all the questions in COMEDK 2025 asked from this particular chapter. Okay, let's get started with the first question from 2023. The temperature dependence of the rate constant K is expressed as this equation, that is your Arrhenius equation. When a plot between log K and 1 by T is plotted, we get the graph as shown. What is the nature of the slope in the graph? Okay, what's the value of the slope in the graph? Sorry. So I have this equation where I have K equal to A into e to the power of minus EA by RT. So log K equal to log A minus EA by 2.303 R into 1 by T. This is the equation. Okay, now what is there? What is the slope here? Y is equal to C minus M into X I can write. Okay, so what is the value of the slope? EA by 2.303 R, right? Minus EA by 2.303 R. So option number B here. Next, consider the reaction P to Q. The concentration of both the reactants and the products varies exponentially with time. Which of the following figures correctly describe the change in the concentration of reactants and products with time? So if you see that reactants concentration is decreasing and products concentration is increasing. So I have here P is the reactant, so P concentration will decrease and Q concentration will increase, right? So I have this one, option number B. Here what is the problem? Here you can see, okay, P is decreasing, Q is increasing, but the increase has to be in this way. Okay, it is not like this. If you have seen the graph, it is in this way the product increases. Here there is a linear increase in Q, so that is why it is wrong. And here you can see Q is decreasing and P is increasing, that is the reverse, so that is also wrong. Next, for the given reaction, the possible mechanism is this one. What is the rate law and the order of the equation? Okay, so now if I see that the rate is determined by the slowest step, right? So in the slowest step, what I have? N2O2 and H2. So how I can write? Rate will be equal to K into, okay, or rate will be proportional to K into N2O2 into H2. Right? But if you see in the final equation, we don't have N2O2, right? This is not there in the final equation. In the final equation, I have 2NO gives me 2 plus 2H2 gives me N2 plus 2H2O. So that means I cannot have N2O2 in this equation. I have to represent it in a different way. So I can see the first equation. There I can write K equilibrium is equal to N2O2 divided by NO square, or I can write it like NO square K equilibrium is equal to N2O2. Now substitute this value in K in this place, so I will get rate equal to K into, for N2O2 I have K equilibrium into NO square, then I have H2. Okay. So now this one can be written 1 K dash, where I have taken it as a concentration and I have H2. Okay, so I have NO square and H2. So okay, fine. If I see that all the reactions are given in terms of N2O2, this option is not there, so we can talk in then directly in terms of this one. Okay, so if this option is there, this one will be the answer, but we have been given all with N2O2, so that means this one will be there, N2O2 and H2, and that is because we have slowest step and order will be 2, so option number B here. Okay, if the order, in the option the questions are given in terms of NO, then this has to be the answer. Okay, next, the energies of activation for the forward and reverse reaction for A2 plus B2 gives 2AB are 180 and 200 kilojoule per mole respectively. Okay, The presence of catalyst lowers the activation energy of both the reactions by 100 kilojoule per mole. The enthalpy change for the reaction in the process will be. Okay. So now you can see that for forward reaction the activation energy is 120, 80, and for backward reaction it is 200. Okay. So that means obviously the graph has to be like this. See, this is A2 plus B2 and this is AB. So now you see this graph, activation energy for this one is 180 and the activation energy for this one is 200. Okay, the backward reaction activation energy is 200, forward reaction activation energy is 180, right? This is there. Now the question is saying that when you use catalyst, both of them decrease by 100 degrees. So that means, let me do a bigger one so that I can show you properly. Wait, let me do a bigger graph here. Okay, this one, okay, from here to here, this one value is how much? 180. Okay, and then I'm writing here, this value is 200. Now when I'm using a catalyst, let me use a catalyst. Okay, with catalyst what will happen? Both of them will decrease by 100. So now what is this value? 180 minus 100. So this is 80, and now this value, this value 200 minus 100, that will be 100. Okay, so what will be the energy difference between the reactants and the products, right? So what is this energy gap? 80 minus 100, that is your minus 20. So option number A here. Okay, next, two plots are shown below between the concentration and time t. Which of the orders are given in the graph respectively? So here it is concentration at any time and concentration. So if you see the for zeroth order, I have A naught minus A is equal to K into T, right? So this A is nothing but A minus X, right? The concentration at any time. So if I take that in y axis, then I will get A naught minus K into T. So the negative slope I will get K, and I'll have a y intercept. So this is definitely zeroth order reaction, so I can have these two options eliminated. So whenever there is first order reaction, you can easily identify it by seeing some log term. If there is a log term involved, then it will be a first order reaction, otherwise it will be a generally zeroth or second order reaction. For second order reaction, what formula I have? 1 by A minus 1 by A naught is equal to K into T. Now this one, 1 by A is equal to KT plus 1 by A naught. Okay, so here K is a positive, Y is equal to M into X plus C. So M is a positive slope here, with K I will get, so, and Y intercept is also there. So zeroth order and second order, option number C here. Okay, next, in the reaction 2x gives you y, the concentration of x decreases from 0.5 to 0.38 in 10 minutes. What is the rate of the reaction in second inverse, molar second inverse? Okay, so the rate of the reaction will be what? Change in concentration by change in time. Okay, d concentration dt. What's the concentration? 0.5 to 0.38, right? 0.5 to 0.38 minus what is the time? 10 minutes, convert it into seconds, 60 seconds. Okay, so I will have 10 minus 8 2, 4 minus 3 1, 0.12 divided by 10 into 1 by 60. Okay, so now if I solve this, okay, just let me solve here. I can write it like 12 by 10, sorry, 100 into 1 by 10, right? 0.12 I can write 12 by 100, then this 10 is there, and then I have 1 by 60. Okay, so 1 by 5 is 0.2 into 10 to the power of minus 3. Here then is I can write 2 into 10 to the power of minus 4. That is option number A here. Okay, Next, for the reaction 2NH3 gives N2 plus 3H2 if minus dNH3 by dt equal to K1NH3, dN2 by dt is K2NH3, dH2 by dt is K3NH3. What is the relation between K1, K2 and K3? Okay, so now first of all let us write the equation here. I can write rate is equal to minus 1 by 2 dNH3 by dt, okay, then minus dN2 by dt equal to 1 by 3 dH2 by dt. This is done. Now what I can see, dNH3 by dt value is given to me, right? Let me substitute that. So what I will get, minus 1 by 2 into dNH3 by dt, I will substitute K1 into NH3. Okay, next dN2 by dt is K2 into NH3. Next here 1 by 3 K3 into NH3. Okay, so I can cancel NH3 here. So what I will get, 1 by, so this minus and plus is not important because minus and plus is just symbolizing which is reactant, which is product, right? Doesn't have anything to do with the values. So minus 1 by 2 into K1 is equal to K2 is equal to 1 by 3 K3. Okay, I don't have any such relation according to the option. Now let me, what I'll do, I'll multiply 3 to the whole equation normally, okay. If I just multiply 3 to the whole equation, I will get 3 by 2 K1, 3 K2, K3. Then I'll get 1.5 K1, 3 K2, K3. So that is option number C here, okay. Next, during the kinetic study of the reaction 2A plus B gives C plus D, the following results were obtained. So let us see that what is happening. I want to find the order of the reaction, right? Or you have to find the rate law. So first of all, to find out that how is the rate changing when you change the concentration of A, you have to keep B constant, okay. So I have to keep B constant. I have first and the fourth reaction where I can keep B constant. What I have done here to here, I have increased the concentration by 4 times, right? And you can see the rate has also increased by 4 times, right? So rate, concentration increased 4 times, rate increased 4 times. So that means with respect to A, it is first order. With respect to A, it is first order. Next, coming to B. If I want to calculate with respect to B, A should be constant. This one should be constant. Here you can see that you are doubling the concentration and this is becoming 4 times, right? You are doubling the concentration, rate is becoming 4 times. That means what it is? Second order reaction. So with respect to B, it is second order reaction. So option number D here. Next, what will be the rate equation for the reaction if the order of the reaction is 0? Okay, order of the reaction is 0 means there should not be any concentration power given. Okay, here if I see x to the power of 0 and y, that means it will become k into y, but that is not there because we have order of the reaction should be 0. Okay, here I will get order of the reaction as 1. Here also I will get k into x, so order of the reaction is 1 again. Here I will get order of the reaction is 2, but only option where I will get order of the reaction 0 is option number B. Okay. Next, if the rate equation for the reaction is given the order of the reaction, so you have to just add the order 1 and 1 by 2, that is 3 by 2 or 1.5, option number C. Next, an endothermic reaction with high activation energy for the forward reaction is given by the diagram. So endothermic reaction means what? The product energy will be more than the reactant. So remember, for endothermic, what is the condition? Product energy will be more than the reactant energy, and that is present in which graph? That is present in C and D. In A and B, the product energy is less, right? And here something is given is high activation energy. Here you can see the activation is very small, here the activation energy is very much big. So the correct answer will be option number C. Let's see the next question here. A reaction is given as 2P plus Q products if the concentration of Q is kept constant and the concentration of P is doubled, then the rate of the reaction is. So I can see that from this, one second, yes. So from this equation I can write rate is equal to K into P square into Q, right? if I double the concentration of P, then rate will become 4 times, right? Because 2 to the power of 2 will become, so the rate will be quadrupled, option number C here. Next, 3A plus 2B, the rate of the reaction dB by dt is equal to. So I have rate is equal to, okay, minus 1 by 3 dA by dt is equal to 1 by 2 into dB by dt. Right? So now what I can say here, that dB by dt will be equal to 2 by 3 of dA by dt. So that is option number B. Okay. Next, 90% of a first order reaction is completed in 70 minutes. The velocity constant of the reaction is. So it is a first order reaction. Directly formula I can write K equal to 2.303 by T log of A naught by A. Right. So I have here, I have to calculate the velocity constant. Okay. So 2.303 by time is given to me 70 log of, okay, 90% is completed, so 10% will be remaining. So 100 by 10, 100 minus 90, that is 10. So I will have log 10 1. So here I have, so I can write 2303 into 10 to the power of minus 3 divided by 70. So I can say that 70 into 30 will be 2100 into 10 to the power of minus 3. So I am just rounding it off to 2100 because I know that will be divisible. So this is where you can use the trick. So I will get 0.0, 1, 2 and 3, right? 0.03 I will get something. So that is the nearest answer is option number A here. Next, RCOR plus H2O gives you RCOH plus R dash OH. This type, what type of reaction is this? So it is your ester hydrolysis in acidic medium, and we know this is an example of pseudo first order reaction or pseudo unimolecular reaction. Next, how enzymes increases the rate of the reaction? Increases by lowering the activation energy, right? So they provide an alternative method for the reaction where the activation energy is lowered. Next, for a reaction X to Y, the graph of the product concentration versus time came out to be a straight line passing through the origin. The graph of minus dx by dt and time would be. So it is a straight line passing through the origin, right? And we have this one, a straight line with a negative slope and an intercept on y-axis, a straight line with a positive slope and an intercept on y-axis, a straight line parallel to x-axis, a hyperbola. So if you can see that, first of all, it is giving that it is a straight line. So hyperbola cannot be the answer, right? Next, it is saying that it is passing through the origin. So if it is passing through the origin, then we cannot have a negative intercept. Okay, we cannot have a negative slope if it is passing through the origin. So for passing through the origin, a straight line parallel to the x-axis is also not there because it cannot pass through the origin. And next, a straight line with a positive slope and an intercept on y-axis, that is possible. I can have like this. Okay, so I can get the answer as option number B here. Okay, next question. Let us see the next question here. In a chemical reaction A plus 2B, when concentration of A is double, the rate of reaction increases by 4 times. So with respect to A, it is a second order reaction, right? And when the concentration of B is double, the rate continues to be same. That means with respect to B, it is a 0th order reaction. So the overall order is 2 plus 0, that is 2. Okay. Next, the rate of chemical reaction doubles for every 10-degree rise in temperature. If the temperature increases by 60 degree, then the rate of reaction increases by 60 degree, 0 to 60 degree, right? 6 times you are increasing, so it is 2 to the power of 6, 64 times, option number C here. Next, the endothermic reaction A to B has an activation energy of x kilojoule per mole. If the energy change of the reaction is y kilojoule, then what is the activation energy for the reverse reaction? Okay, so I have an endothermic reaction, so the graph will be like this. And for the forward reaction, what is the activation energy? X. And for this one, that is the energy change of the reaction is y. So what is this gap? That is x minus y, right? So option number B here. Next, AP plus BQ gives you product where P is doubled keeping Q constant. The rate increases by 2 times. So I can write like this, Okay, so you can see that the rate increases 2 times when P is if P is doubled, rate increases by 2 times. That means with respect to P it is a first order reaction, and then when P is constant, and when Q is doubled, the rate increases 4 times. So with respect to Q it is a second order reaction. Overall order will be 3. Next, for a reaction between A and B, the order with respect to A is 2 and the order with respect to B is 3. So I have R K A square and B cube. Okay. Next, the concentration of both A and B are doubled, the rate will increase by a factor of. So this one will become 2A square and this one will become 2B cube, right? So 2 2s are 4 and here 2 2s are 4, 2s are 8. So it will increase by 32 times, option number C here. Next, a reaction is 50% completed in 2 hours and 75% completed in 4 hours. So if I have 100%, first 50% will be completed in 2 hours, and after that from 50 to 25 it will take another 2 hours, right? So total from 100 to 25. I was started with 100 and I am reaching now at 25. So how much I have completed? 75% in 4 hours, right? The initial concentration is independent of the half-life is independent of the initial concentration. So this is your first order reaction A. Okay, next, the time required for 100% completion of a 0th order reaction is. So if I want to complete 100%, okay, then this A will become 0. So I have time equal to A naught by K. A by K, that is option number A here. Easy question. Next, the decomposition of NH3 on the surface of a platinum has a rate constant of 2.5 into 10 to the power of minus 4 moles decimeter cube second inverse. The order of the reaction is. So if I have this one, that is rate constant K equal to moles for any order reaction 1 minus n liter n minus 1 second inverse, right? And now here if I compare, the unit of mole is 1. Okay, so I can compare this one with this one. 1 minus n equal to 1, so n will be equal to 0, option number A here. Next, the rate equation of a gaseous reaction is given by R is equal to K into A into B. If the volume of the reaction vessel is suddenly reduced to half of the initial volume, the reaction rate relating to the original rate will be. Now see here, I have R is equal to K into A into B. Okay, now you have reduced the volume suddenly, right? So R dash will be K into 1 by 2A or B by 2A, right? Next, what we have, the reaction rate relating to the original rate. So reaction rate relating to the original rate means new rate by this rate. So I will get here what? K into A by 2 into B by 2, and here I will have K into A into B, right? So this all will get cancelled and I will get 1 by 4. So that will be equal to option number A here. Next, the activation energy for the reaction A gives B plus C at a temperature T Kelvin was found to be 0.04606 RT joules per mole. What is the ratio of Arrhenius factor to the rate constant of this reaction? So now if I want to calculate, this is 2024 question, we have this equation, right? Log of K, okay, is equal to log A minus EA by 2.303 RT. Now what I can substitute in the place of EA? 0.04606, right? Right? This is also there. So RT will get cancelled, and this side I have log K minus log A. So I can write this side log K minus log A, right? Let me come down here, you can see. So now I can write down this one as log K by A, okay, is equal to 0.04606 divided by 2.303, okay. So now what I can do here, you have a minus here, right? So this one also can be written like this, log of A by K is equal to, here I can put minus 0.04606 divided by 2.303. Now if I see here, what I can do, log of A by K, okay, because I want to find the ratio of Arrhenius factor to the rate constant, right? Now you can write down this in the form of 4606 divided by 1, 2, 3, 4, 5, 10 zeros, like 4 zeros into 2303 divided by, okay, this is there, so this one will be there, so 1 by 5 I will get, 1 second, 1, 2, 3, 4, 5, 1, 2, 3, 4, okay, one more 0 is there, so I will get 4.606 and this side 1000, okay, so I got 2 by 100, 1 second, let me just solve it, or I'll get 1 by 50, right? I will just check once again this calculation. So I got 0.0406 by 2.303. I wrote 4606, 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 2.303 1000, 3030 cancelled, 2.3032. So I will get 2 by 100 or 1 by 50. Okay. So now what you have to do, you can take this one, or I'll just write it as 2 into 10 to the power of minus 2 or 0.02, right? So A by K value will be what? 10 to the power of 0.02. Okay. Now see very carefully, log 1 value is 0, right? Log 1 value is 0 and log 2 value is 0.301. So now if I want what log value will give me 0.02, I have to find that number here, right? Now you see that it has to be something greater than 1, less than 3, less than 2, right? So you can see this number is not greater than 1, this number is not greater than 1. I have this number and this number. Now see, 1.5 comes in between 1 and 2, like exactly in the middle. So you can find that that value will not be 0.02 definitely, because that is a very less value. It can be 0.2 something, right, but not 0.02. So for getting 0.02, it should be very close to 1. So I can find 1.047 much closer to 1. So option number D here. Next, in the presence of a catalyst at a given temperature of 27 degrees Celsius, the activation energy of a specific reaction is reduced by 100 joules per mole. What is the ratio between the rate constants for catalyzed and uncatalyzed reaction? This is very simple question. So let me write for catalyzed reaction the equation as A into e to the power of minus EC by RT. Okay, and for uncatalyzed reaction, e to the power of minus EU by RT. Okay. Now if I divide both of them, catalyzed by uncatalyzed, okay, AA will get cancelled. Next I have e to the power of minus EC by RT, okay, plus EU by RT. Then I have E, I can take EU minus EC by RT, right? Then I have e to the power of 100 by RT. Okay. Now this is for Kc by Ku. Now you can take log of both of them, right? Log Kc by Ku is equal to 100 by 2.303 RT. Okay. Now 2.303 into R is 19.1. So please remember that is 19 you can take, and temperature is given 300. So I have 100 divided by 19 into 300. Okay, so I have 1 by 57. Okay, now if I want to calculate 1 by 57 is how much, you have to find the ratio of this one, right? So 1 by 57 is 1.0. I have taken here ln on both sides, then I'll get 2.303 log, I'll get log Kc. So what you have to find? The ratio between these two, right? So Kc by Ku I have to find out. So I got this one, 1 by 57. So what is Kc by Ku? That is 10 to the power of 1 by 57, right? Now if you see this one, 1.1 by 57 is how much? If I just divide this one, I can have 57, 43, and then 4 I can have 8 7s are 56, no, 7 I can have 7 7s are 49, 35 plus 4, so 0.017 something I will get, right? And 0.017, how can I represent it? So now again you see here, log 1 is equal to 0 and log 2 is equal to 0.3, and I need something which is very close to log, means that number should be very close to 1 so that I get 0.017, right? But it should be greater than 1 because it is a positive number, right? So it should be greater than 1, so definitely these numbers will not come, and 1.97 means almost close to 2. So the correct answer here again will be option number D. Okay, 1.04 will give me a value near to that. Okay. Next, for a given reaction x plus y gives you z, the order of the reaction with respect to x and y are m and n respectively. Okay, so rate is equal to k into x to the power of m and y to the power of n. Next, if the concentration of x is tripled and that of y is decreased to 1/3, what is the ratio between them? So if this one is tripled and this one is reduced by 3, so what I will get, r dash by r will be, see, this one divided by this one, right? So I will have k into 3x to the power of m, y to the power of n whole divided by x to the power of m, and I have y by 3 to the power of n, right? Now if I see, I will get 3 to the power of m, and I have this one 3 to the power of, I can write it like this, r dash, so just a minute, here I made a mistake, this is y by 3 to the power of n and y to the power of n. So I will get 3 to the power of m and 3 to the power of n. So that can be written as 3 to the power of m minus n, option number A. Next, last question, which is an example of pseudo first order reaction, acid hydrolysis of glucose or sucrose, sorry. Okay, so students, these were the top 30 questions from chemical kinetics, previous year questions, very important. Do practice them. Any doubt in any question, put down in the comment section, I'll definitely address to it. And do not forget to subscribe the channel because many more things are coming up in this channel. Okay, all the very best. Please work hard and keep subscribing and do like this video.